If you've tried streaming data from a Kafka topic into a data lake, you know the pain. There could be fragile pipelines that break silently, duplicates you don't catch until somebody asks why the numbers are wrong, schema mismatches, type conversions that fail at the wrong time. Even if you're using the open source Iceberg connector for Kafka Connect, it can be difficult. You can wind up with small files, lots of table maintenance. All kinds of things can be difficult. I clearly don't want to discourage you from using streaming. I think it's a key technology, but the streaming data lake interface has not been simple. And that's another reason why, especially when a company is adopting streaming, we still see this very robust operational analytical divide. Now, this has been with us for decades for perfectly valid reasons. The whole fact that we're talking about data lakes in this course is, an acknowledgement of the analytical estate separate from the operational estate. But if we've got a lot of streaming happening over on the operational side, bridging the gap can be difficult. And adding AI to the equation only makes it more urgent. AI needs fresher, more real-time data to be useful, especially when we consider agentic applications that are trying to take action on unstructured data and vague sort of probabilistic outcomes, the sorts of things we're asking agents to do, and then go do things in the business. Those need to be operating on up-to-date data. It just makes the whole streaming problem more urgent. Imagine you run an online store and customers are browsing right now. If you send some recommendations hours later, well, they've left. That doesn't work. Those recommendations have to be real time. And if they're going to be informed by AI, that AI needs to be operating on timely context. So we need to see what we can do about unifying this operational analytical divide. So what do? Well, we've got Kafka, we've got Iceberg, these are open source things, we've got a connector, Kafka Connect. We could just throw that in there, as I said before, and now you have a choice to make. You can choose fast writes, you get a lot of small files and bad read performance, but fresher data, more data in more quickly. You could choose slower writes, they give you properly sized files, but at much lower freshness, higher latency. You have to wait longer for the data to get into production. You don't want to have to pick your poison. Enter Tableflow. This is Confluent's easy button to this whole mess. It takes a Kafka topic and makes it available as an Iceberg table or a Delta Lake table with the push of a proverbial button. That's any topic that's got a managed schema turns into an Iceberg table. Data flows into the topic, becomes available in the data lake as an Iceberg table. And it really is that easy. Let's talk a little bit about how it works. Once you enable Tableflow on an existing topic, so now we're talking in the world of Confluent Cloud. We've got a topic in Confluent Cloud, and you click, you say, I would like Tableflow. You need to hydrate that Iceberg table really quickly. So the first step is Tableflow is going to ask the broker where the data is. It's then going to read segments in parallel straight from object storage. There's no load directly on the broker. Because remember, this is like a high-speed hydration thing, and you could really swamp the broker if you're trying to do that quickly. So we're going to go get that from object storage. Unlike normal consumers, you're not limited by partition count. We're just kind of slurping this in as quickly as we can and materialize topics of some size very quickly. What happens next? How does the data end up as files in the Iceberg table? Well, that's the job of, internally, we call this the Tableflow materializer. Really are kind of lifting up the curtain inside Tableflow. It is an easy button, okay? You press a button, you say, I want this to be Iceberg, but under the covers, there's this thing called the materializer. After reading the segments, the data segments from object storage, converts them into Parquet files, which they have to be, and uploads them to where the Iceberg table is supposed to live. There's no commit in Iceberg yet. These are just data files. Along with each file, well, the materializer does what it has to do, prepares the metadata. You've got the manifest list, metadata file, all of that stuff. Those need to be created, and then it sends them to another internal component called the committer, and there's one committer at a time working for each table. So that committer takes those task inputs from the materializer, comes up with an efficient plan, and batches up the writes of metadata into object storage, which lets it eventually make a single atomic commit in Iceberg, creating a new snapshot, plus storing the last committed Kafka offsets. And because it's storing contiguous ranges of commits only, and Kafka offsets are stored atomically in Iceberg, that gets us exactly once delivery from the Kafka topic into Iceberg. After that, the new table state is visible to queries. And from then on, streaming writes happen fast, but unavoidably, they're going to create a lot of small Parquet files. It's not like you want to wait an hour to commit data into Iceberg. You're going to be doing that frequently. That's bad for queries, all those small files. There's more metadata I/O, inefficient scans. Nobody likes that. Well, Tableflow is well aware of how difficult it is to ingest streaming data into a data lake, which is why it includes a compaction service to optimize read performance. It would be a terrible citizen if it didn't, right? It's this streaming solution and it's going to leave compaction up to somebody else. Absolutely not. It takes responsibility for that itself. It merges small files into properly sized files and submits them to Iceberg as their very own snapshot. And this is always running in the background. It's just not a thing you need to think about. So that's a little bit of how Tableflow works behind the scenes. All you really need to know is it's a Kafka topic that turns into an Iceberg table. But a little bit of the implementation is kind of cool. Here are the benefits you get. Like I said a minute ago, you get exactly once delivery. There's no duplicates. Kafka offset commits and metadata commits are happening atomically. There's no load on the brokers. Tableflow reads directly from object storage, so your Kafka cluster doesn't feel it. Particularly important on ingest. Now, your Kafka cluster is probably a fully managed thing in Confluent Cloud at this point, so you're not really thinking about broker load anyway, but this is just a nice thing to know that you're just never going to see this in any kind of performance graph because we're not hitting that internal broker. Compaction on Tableflow tables is automatic. Now, hopefully you are looking after compaction in your data lake anyway, but it would be, kind of rude to be the streaming Iceberg integration and not look after your own compaction. So Tableflow does this on its tables. Very, very important. Now you have a single source of truth. Streaming, that is the operational concern, and analytics, they see the same data. Why? Because it is the same data. There's not an ETL job in between them. There's not some process that you have to run. That is, be careful with the word, but pretty revolutionary that the operational and analytical state are actually unified here. It's a very, very important thing happening. You have configurable freshness. You get to balance latency and cost for each use case. So how long are you going to wait before you take some streaming messages and make a Parquet file? That is up to you to determine. Of course, that's going to be some period of time. It's not going to be one Parquet file per commit in Kafka or per message in Kafka. But you get to tune that knob. Tables can live in your S3 bucket. You own the analytics data. That's probably where the rest of your data lake is, in some bucket of yours. Well, we get to keep that. Completely standard Iceberg. And if you would like Tableflow or Confluent Cloud to act as a catalog, it's a fully REST catalog compliant API. Any Iceberg tooling works. If this is your entree into Iceberg, we are your catalog. And if we're not your catalog, well, we integrate with AWS Glue, Snowflake Open Catalog. As of this recording, Unity Catalog is coming soon, so you have options there. And as always, you can query from anywhere. Athena, Redshift, Snowflake, Dremio, wherever you are, Tableflow data is Iceberg data. So you can read it from wherever you like. Tableflow solves the streaming to analytics problem. One flow, unified data, automatic maintenance. Depending on where you're viewing this video, either in the description or on this webpage, there is a code for getting started with Confluent Cloud, so you can start experimenting with that right away, which of course I encourage you to do.